Good afternoon, everyone. Welcome to this webinar. As the title implies, this is all about color, and you can see two logos in the left-hand side corner, one for pdfToolbox, the other one for CoPrA from Color Logic. Those are two of the applications that we'll talk about. What we'll talk about is actually a little bit of color theory, because we get a lot of questions about ICC color and what the possibilities are, and specifically about the difference between ICC profiles and DeviceLink profiles. And that's something that is quite important. It can be of very practical importance in workflows. So it's important that you realize what the differences are, what you can use for what. And then the second part of this webinar will explain, once you know the difference between ICC profiles, generic ICC profiles and DeviceLink profiles, and we'll explain which software you can use to work with ICC profiles and work with DeviceLink profiles, where you can create them, how you can get them, and what you can use them for. So this is partly theory about color and partly real applications and more down-to-earth, hands-on if you want. Now, these webinars typically last about an hour. I'm going to try and keep to that today as well, and that means that if we start talking about color theory, it's going to have to be summarized to a great extent. And I've tried to keep things as simple as possible. If you know a lot about color, I hope I have not oversimplified, so you'll have to bear with me the first couple of minutes, but then the applications with software are probably going to be more useful for you in that case. So bear with me through the color theory explanation, and we'll do the hands-on as much as we can afterwards. Last point, if you have any questions, then you have this questions area in your GoToWebinar control panel. Simply enter it in there, and I will either look at them and answer them while I'm talking, or I will come back to your question at the end of the webinar. If you have something specific, like I said, the last slide also has support and other email addresses. You can always send in your question about your specific workflow or your specific client. You can always send that in to us through email as well, of course. Okay, let's get started. And like I said, I've tried to keep things as simple as possible. And my feeling is that while cutting some corners here and there and perhaps not explaining all of the details, it is actually possible to explain ICC profiles and DeviceLink profiles in theory in a very easy way. And what I've started with here is a first slide that contains red. Unfortunately, it contains two objects, and both of them are defined as red, and you can already see that there is a little bit of a color difference between the two. If you know anything about color, then you would be right to guess that on the left you have RGB red, and on the right-hand side you have some CMYK red. And because this is PowerPoint on Mac that I'm using, it will actually allow me to define a rectangle in RGB black and CMYK black. So that's just what I've done. And you can see that even though both are supposed to be the same color, there's quite a bit of difference. Just to say that there is some importance in how you express color in files. Sure, you all know that. That's why you joined the webinar in the first place. But that's kind of the basic statement, the opening statement for the whole story. And while you could say, well, yeah, it's RGB and CMYK, and the color models are different, and one is typically with light, the other is typically with something like paint or ink. So it's normal that it's different. Well, let me take the next slide, and you'll have to look very closely. It is actually very difficult to see. I imagine it's even more difficult to see through GoToWebinar. But if you look closely, you'll see three different shades of red. And unfortunately, all three of them are RGB. So apparently even saying that the red is RGB isn't good enough. There are still some variations. And rather than letting you get a headache from staring at this RGB red, let me swiftly advance to the next slide. Well, actually, all of these are red as well. In order from left to right, you have something that is expressed in an ISO-coated profile. So this is the kind of red on the left-hand side that you would see when something is printed in CMYK on a coated paper, and then you have an uncoated paper in the middle and an uncoated yellowish paper on the right-hand side. So the differences here are, of course, much, much bigger than what you saw on the RGB side. And while if you look at the RGB side and you see those subtle differences, you could still wonder whether you should care about these differences and whether that's ever going to be a problem in the workflow. If you look at this slide where you see three totally different colors, where all of them are pure red but simply have a different profile attached, then you can see that, yes, these are very important and we need to take these into account. Now, I've already said the magic word. What you're looking at here are images. These are three images designed in Photoshop, and all three of these images have a different ICC profile attached. The left-hand side one has ISO-coated attached, the middle one is ISO-uncoated rather, and the right-hand side is ISO-uncoated yellowish. Now, what does it mean when I say there is an ICC profile attached? Well, an ICC profile identifies that color space. And what does that mean? Well, it gives me the characteristics of a particular color space, which allows me to say, I'm going to paint this red. And if I say I'm going to paint this red in the color space identified by this ICC profile, that should tell someone else exactly what that means. So that ICC profile takes something where you can have a lot of variation, and if you want is a passport or an identity card for that color space. And there are two main characteristics. There's a bunch of others, but I already said I'm simplifying. There are two main characteristics that it details. And the first one is very well known and is the color gamut. The gamut is the collection of all of the colors that can be reproduced or seen or printed or scanned or photographed or whatever it is that can be reproduced in that particular color space. So a color that falls outside of this 3D representation that I have here, I can simply not reproduce. In the case of ISO-coated, when I talk about CMYK print, for example, that would mean that I have a color that I cannot print. If I try to print it, it will come out as something different, something looking paler or with a different color hue or shade in it. So you simply cannot reproduce that. And every color space that you define has such a gamut. What you see on screen is, on the left-hand side again, that ISO-coated color space, which is a relatively large color space. So printing in ISO-coated is relatively good at reproducing color. On the right-hand side, rather, you have ISO-uncoated, and you can already see that the gamut of that color space is a lot smaller. And if you remember the previous slide where I had those three red colors, the fact that the red on the right-hand side and in the middle is so much paler than what I have on the left-hand side is precisely because of the fact that the gamut of that color space is smaller. So it gets clipped, the bright red, if you want, gets clipped to something that is a lot paler. Now, that's the first major concept that you have in an ICC profile, that concept of a gamut that identifies which colors can be expressed. And then, of course, there are much more colors than what you have here. In theory, there is an infinite number of colors. And so the second part of an ICC profile that is very important is an identification of each of these colors in terms of an abstract color space. What you see here is on the left-hand side the profile color space, or the input color space, which is CMYK in this example. And on the right-hand side, I have something that is called LAB, and LAB is a theoretical color space that is infinite. You can represent any color. It has a gamut that doesn't restrict the colors in there. So what that ICC profile does is provide a relationship between the input color space, CYK, and the profile color space, LAB. And that means that if I have a set of LAB values, that this profile will define how that color is painted in that particular color space. If we think about the red again, if this was one of those uncoated color spaces, and I have an LAB value that represents very bright red, then this arrow that goes from LAB to CMYK identifies how that red, that bright red, is transformed, and thus how it will be printed on that uncoated stock. So it gives me that relationship. And it's important that it gives that relationship in two directions. I can calculate either from CMYK to LAB, or I can calculate from LAB to CMYK. Now, not every ICC profile has LAB as an abstract color space. There are other possibilities. XYZ is another one. But because all of those are theoretical color spaces, infinite color spaces, it is possible to calculate between all of them without losing any detail. So the only thing you have to remember is that there is a device-specific color space on the one hand side, and that there is an abstract infinite color space on the other side. And that's a standard ICC profile. Now, let's relate this to something that you are probably more aware of. If I have a pdfX1A document, and as you know, pdfX1A is, at the moment today, still the most used standard in graphic arts. Now, if I have a pdfX1A document, what kind of colors can I have in there? And basically, pdfX1A restricts the color spaces to CMYK or gray or spot color. Those are the possibilities. And even more importantly, it states that the content objects, so the text and the images and the vector elements that you have in that pdfX1A file, cannot use an ICC profile. Now, this is kind of worrisome because pdfX1A was invented to exchange PDF between parties without there being a need for communication. I'm supposed to be able to make a pdfX file and then give it to you, and you are able to print it, and it will be exactly what I had in mind. That's the aim of the pdfX standard. Now, if I'm allowed to include device colors in there and have text in there where I say this uses 0, 100, 100, 0 as CMYK components, which is bright red, then that's a little bit worrisome because that's not well defined. We just saw that there are different versions of CMYK red, and I need to be able to specify which one it is. Well, what the pdfX standard says is, or the pdfX1A standard specifically says, is that the objects in the file cannot contain an ICC profile or cannot have an ICC profile attached, but the file as a whole, the whole pdfX1A file, must contain an output intent, and that output intent must contain an ICC profile. So the ICC profile is there. It's just put in a special location in the document in that output intent. And if I look at a pdfX1A file and I see a piece of text in there that identifies its color as 0, 100, 100, 0, then I know that I have to look at the output intent, because the output intent is the identification of the color space that the file was created for. So there is this combination of using device CMYK for the content objects, which is CMYK without ICC profile, but then specifying the ICC profile in an output intent. And actually, if you open a PDF file in pdfToolbox, then immediately at the bottom of the window, as you can see here in the screenshot, immediately at the bottom of the window, you'll see two very important parts of information. The first one is that pdfX1A badge that you recognize there, the yellow badge, which says that the file is compliant to the pdfX1A standard. And the second thing that you see in there is the name of, in this case, CoPrA 39 isocoated V2 ECI. Well, that's the name of the ICC profile, the output intent that is used in this particular pdfX1A file. So you know immediately that this is a standard file and that the color in this file is in accordance to that ICC profile that I have in there. That's what happens in a pdfX1A file. All of the color is well defined. There is no worry. Except, of course, that in many workflows, there is something to worry about. A file that comes in, specifically when you have ads that are delivered, for example, a file that comes in will come in as pdfX1A. It has this ICC profile attached in the output intent. And then I want to print it, but I want to print it on a paper or on a machine that uses a different color space. So a different ICC profile. And the example you see here is of someone delivering a file to me that has isocoated V2 as the output intent. So I know that all of the color is designed in isocoated V2. And then printing that on an ISO uncoated device or in an ISO uncoated workflow. And of course, you know that the result is going to be different. I mean, it's never going to look the same because the gamut that you have on the right-hand side is much smaller than the gamut that you have on the left-hand side. But the question is, of course, how do I do these transformations from ISO coated to ISO uncoated? And again, ICC profiles are the key, and this is very important to realize what happens here if afterwards you want to understand what will happen in something like pdfToolbox or in ZePrA when you start doing color transformations on documents. So what happens here? Well, what happens is that there are two ICC profiles involved. On the left-hand side, ISO-coated, and on the right-hand side, ISO-uncoated. And luckily, if you look at the number 2 I have in these slides, those two ICC profiles have something in common. They have in common that there is an LAB color space in them. And I said that LAB is a theoretical, infinite, abstract color space, which everyone knows. It's well defined. There is no limitation because of a gamut or aren't multiple versions. It's a very well defined color space. And so I can use that to do color transformations from one CMYK space to another CMYK space. And another way to think of it that might be easier if you're having trouble with the theoretical color stuff is, let's assume that I'm on the left-hand side and I speak French. And let's assume that on the right-hand side I have my neighbor and my neighbor speaks Italian. Now, if I speak only French and my neighbor speaks only Italian, we're going to have a little bit of an issue. If both of us speak something that we have in common, English, for example, then it's much easier. I can translate whatever I want to say in English, and my neighbor simply translates back from English to Italian. That's something we do all the time. And it's exactly the same as what happens here in a workflow where you have multiple ICC profiles. If I have in my PDFX file a color that is defined as pure red, 0, 100, 100, 0, then I can put that in where you see number 1 in this ICC profile on the left-hand side. And there is this red arrow that allows me to transform that color to LAB. Now, those LAB values are absolute, so I can put them in the second profile on the right-hand side. On the right-hand side of the equation, where LAB is. And then that red arrow that I have in that profile can be used to convert that LAB back to CMYK. Now, if you take an application like pdfToolbox and you ask pdfToolbox to convert this PDF file, and that PDF file contains ICC profiles, and you ask it to convert to ISO coated or ISO uncoated or a swap or whatever profile you want, then this is essentially what you're doing. You're putting those values, those color values, in one ICC profile. You're extracting LAB as a common color space, and you're putting those LAB values in the second profile involved and calculating that back to CMYK. You could do the same trick to go from RGB to CMYK or CMYK to RGB. So converting from ISO-coated, for example, to an sRGB color space is exactly the same trick. You always use that LAB color space, that abstract color space, as a common denominator between, and then you calculate from one to the other. You would think that that would be the end of the story, and in my experience, most people have more or less understood what's going on up to that point. Unfortunately, this approach has a lot of problems, and in order to fix the problem, we need to talk about DeviceLink profiles. So that's the last part of this theory session. What's the problem to begin with? Well, you can already kind of guess it from the language analogy that I made. If I'm French and my neighbor is Italian and we both speak English, and when we do translations, chances are good that what my neighbor understands isn't exactly what I said to begin with, and vice versa. Lost in translation, right? So the same thing here, and I did the exercise. The numbers aren't crucially important, and they will differ depending on what software you use and so on. But basically what I did is I created a black color in Photoshop. So CMYK black, I was nice about it. I said 000 100%, looks very black, and Photoshop is happy. Then I asked Photoshop to convert that to LAB. And the LAB values that I get out are 901. And then I did the same thing that we had on our diagram here. So I took those LAB values and I put them through a conversion to ISO uncoated. And if you look at what Photoshop did, then it's a very good representation of the problem. What I got back as separations after that is 85, 66, 48, 82. Like I said, the numbers by themselves aren't crucially important. What is very important is that on the left-hand side, I have this nice pure black, and on the right-hand side, I have basically garbage. I have something that contains a lot of color in all different separations, and that will probably not print very well. So can you do transformations, color transformations based on ICC profiles? Yes, of course you can. And in some situations, it might not be even a big issue. If I go from CMYK to sRGB, for example, then fine, you'll get something that is usable. But if you expect to do ICC profile-based color conversions from CMYK to CMYK, and it is important to you how the separations are done. In other words, it's important to you to have pure colors and pure secondary colors like red and green, blue, and even tertiary colors, then that ICC profile conversion has a serious flaw. And the flaw is that you're converting through LAB, and you're probably going to lose all of those nice separations on the other end. And in many cases, that's not acceptable. So what can you do? We already kind of know the answer. What we're going to do is use a DeviceLink profile. And a DeviceLink profile, if you remember the story about these two ICC profiles, if you look at this thing, we're actually going to compress this into one profile. So a DeviceLink profile is still an ICC profile, but the difference is that it now has an input and an output color space that are both device-specific color spaces. In the example that we've been using, you have a DeviceLink profile that has ISO-coated V2 as the one color space, and it has ISO-uncoated as the second color space. And these arrows that I have in the middle, well, those now do a direct transformation from CMYK to CMYK. And that means that in such a DeviceLink profile, I can build a whole list of special rules that say, if this is a pure black, I want you to keep that pure black. Or maybe I want to convert that pure black into something that has 20% of magenta under it, simply to make it look a little more black on a paper that I know will otherwise be paler. If I have a pure secondary color like red, this is how I want you to transform it to the other color space and keep it as close in appearance to what I had originally, but still with a nice separation. So the DeviceLink profile still does that color transformation, and it does it directly from an input to an output color space, and it can have a long list of exceptions added so that special colors are converted in a correct way. Now, why would I use a DeviceLink profile? Well, first of all, exactly for what I have on this slide. Transformations from one color space to another color space, in many cases, transformations between different standards, such as a file that is ISO-coated and that I want to print in a swap workflow, or a file that comes out of Japan and uses Japan color, things like that. Transformations between different ICC color spaces. But the second way you can use this is by having an input and an output color space that are essentially the same. Having, for example, a profile that has ISO-coated as input and output color space. Now, why would you do that? You would do that if you want to do something with the separation of a document. And two very common examples. One, I want to print this file, but I know I have a maximum ink coverage of, for example, 300% or 270%. So I really don't want to touch the color if I don't have to, but I have to get the amount of ink used under a certain limit. Well, this will allow you to do it. These arrows that you see here will allow you to do that calculation of the separation on the left-hand side in ISO-coated to a different separation where you take that ink limit into account. Or one step further, not only do I know I have an ink limit, but I really would like to print with as little ink as possible. I want to do ink save. Well, ink saving is, again, something that you can do in the DeviceLink profile. You simply adjust these arrows in between the color spaces to now take away ink, typically take away cyan, magenta, and yellow, and add some black in its place. Take away ink and get something that visually looks the same, but now prints with less ink. So standard conversions and anything that has to do with tech reduction or ink saving are typical applications of these DeviceLink profiles. Okay, so much for the theory, and I've given a lot of a presentation already. I'm not used to doing that. Let me make this a little bit smaller, and let's look at software as well. So now that you know what ICC profiles are and why you would use them and what DeviceLink profiles are, the next step is how do we do this in software? And of course, there is a lot more software than what I'm going to show you here, but you know that we have pdfToolbox in our portfolio. You can actually do quite nice things with color with pdfToolbox. We also have the color logic solutions in our portfolio, and those, of course, are specialized in color. So I'm focusing on these two product families, if you want, to see what we can do here. And the first one I want to look at is pdfToolbox. And what pdfToolbox allows you to do, and instead of reading what is on this slide, let me go to pdfToolbox. What pdfToolbox allows you to do is I can open any PDF file in here. And as you can see, if you look at the bottom here, there is no PDFX compliancy, there is no ICC profile. Well, that is one of the first things that you can do with pdfToolbox. I can go to Standards, I can go to pdfX1A, and then it will allow me to select an ICC profile. And you know now why it allows me to select an ICC profile. It is because pdfX1A needs an output intent, and that output intent needs to contain an ICC profile. So basically, I'm selecting what that profile should be. Now, what is important is that that profile should correspond to how the document was created. If the CMYK I have in here was created in an ISO-coded workflow, if I have percentages that correspond to color percentages that correspond to ISO-coded, then ISO-coded V2, for example, would be a good choice. And if I say execute, it will allow me to give a name for the output document, and I'll just allow pdfToolbox to save that. Once it's done that, you can see that there is now a pdfX1A tag here, and there is an ICC profile. The first very important question is, did I just do any color transformation by doing this? And the answer is maybe. Nothing in color is ever easy, so the answer is maybe. If I had a CMYK file, I put that file through this pdfX creation profile, then the only thing that pdfToolbox will do is insert an output intent. It will not touch the actual color in the document. It will simply tag the document with that output intent. And by doing so, it standardizes it as pdfX1A. So in that case, no, I'm not doing a color transformation. But it could be different. And of course, it also depends on the settings I'm using, but it could be different. Assume that this little nice purple penguin that I have here, assume that that is an RGB image. Well, in that case, if I want to create a pdfX1A file, I have to do a color conversion because pdfX1A doesn't support RGB. So if I want to do this, then I'm going to have to convert that RGB image into a CMYK image. And the way that will be done is that pdfToolbox will look at the ICC profile attached to that image, which should be an RGB ICC profile if it's an RGB image, and it's going to do an ICC profile transformation from that RGB ICC profile to our ISO-coded V2 profile. So in that case, if you set the pre-flight profile up like that, pdfToolbox can actually do that color transformation for you on the fly. I can make what happens a little bit more explicit by looking at the colors tab in here. and you can see all kinds of different things. They all go back to three big processes. The first one is this process conversion one. And if I click that, that shows you that it's going to do an ICC profile-based color conversion. So let's say that I select another output intent, like this uncoated paper one here. Well, if I now run this on the document, I will do the exact color transformation that we talked about during the presentation, going from ISO-coated, which is the output intent in the document right now, to ISO uncoated, because that's the one that I'm selecting here as the destination profile. And of course, this color conversion that I do in this case will have all of the problems that I discussed, because this is purely a color conversion based on ICC profiles. So that's the first thing that you can do with pdfToolbox. It's basically converting colors with a transformation from one ICC profile to another ICC profile. The second thing that you see here in this color group is spot color, and you can see here spot to process as well. That's the same thing essentially. And spot colors is, I already said that PDFX1A allows CMYK, gray, and spot color. Well, that spot color tab allows you to work with these spot colors. And that could be renaming them or mapping them to ISO-coated, for example, or anything like that. It's a little bit outside of what we're talking about today with ICC profiles, but it also supports that kind of processing, number two. And number three, it allows processing based on DeviceLink conversion. And if I click that, I get a list of possible conversions that I can do. And in this case, these things that you see here are all DeviceLink profiles. So all of those go from a particular input to a particular output. And if I think I saw the same one as we've been talking about so far. So this example goes from ISO-coated V2 to ISO uncoated ECI. So again, this is the exact example as what we talked about in the presentation. This is a conversion from an CMYK based on an ISO-coated ICC profile to an ISO uncoated ICC profile. But rather than doing it with separate ICC profiles, this will do it using a DeviceLink profile, and the result will be that you'll have a preservation of those separations, pure colors, secondary colors, and so on. So you'll get typically a conversion that is of much higher quality than what you would otherwise get. Now, what is important, and let me go back to the presentation for a second, and I'll put this one on because I also promised to give you price information for some of these things so that you can see how expensive these different routes would be as well. I'm not going to dwell on the pricing during this presentation too much. I put them in the slides just so that you have them afterwards. But what is important is that you realize that pdfToolbox, both the desktop and the server version, can do these color transformations based on existing profiles. So if I have a file that contains ICC profiles, if I have my own ICC profile that I measured for a particular device, then I can take these profiles and I can use them inside of pdfToolbox. And I just read a question that is exactly the point I'm going to make now. What I said is I can use these profiles if I have them. It's very important to realize that pdfToolbox cannot actually create ICC profiles or DeviceLink profiles. That's not what it does. And what we'll do now is we'll look at a number of other applications that can actually do that. Once again, we'll look at highlights. I don't have time to go into all of the details, but that's the rest of what we will be talking about. And actually, if you think about where do these profiles come from and how can I get either ICC profiles or DeviceLink profiles, then the first possible answer is, well, maybe you don't need software at all to create them. Maybe the easiest and the best thing to do is to simply use existing profiles. And as you can see here, pdfToolbox does have an option. It's called the DeviceLink option or DeviceLink add-on. And that option gives you a list of pre-built DeviceLink profiles that you can use. And if I open this list again, with the exception of the profiles that you see here at the top, which are DeviceLink profiles I created, the rest of these are actually DeviceLink profiles that come with this DeviceLink add-on. So basically that means that you pay some additional money to CAS, and in return you get a number of pre-built profiles, DeviceLink profiles, that will give you higher quality color conversion. And the disadvantage, of course, is that the list in here is relatively limited. But the advantage is that if your needs are covered by this list, then you don't have to learn how to create DeviceLink profiles, and you don't have to buy software to do it. You simply use the expertise of these existing profiles. There is something similar but much more extensive when you look at ColorLogic. ColorLogic has something that they call DeviceLink sets. And a DeviceLink set is, as the word implies, it's a set with device links for a particular market segment or for a particular purpose. And you can see the kind of sets that they have. They have sets where you have profiles that allow you to convert between different standards. They have pre-built profiles to do tech reduction in different market segments. They have pre-built ink-saving profiles, typically with 3 different levels, like normal and then high ink saving and maximum ink saving. And they have profiles to convert from CMYK to gray, or RGB to CMYK, or CMYK to RGB, and so on. And I am going to include the next slide in here and stop a little at this one, because this actually shows you which kind of sets they make available. And you can see that the list of sets that is available from ColorLogic is quite extensive. They have a sheet-fed offset set, for example, that contains conversion profiles for the typical standards that are used within sheet-fed offsets, and then it has tech reduction profiles specifically with the ink percentages for sheet-fed. They have ink-saving profiles, again, specifically optimized for sheet-fed, and so on. And so each of these sets can get you a actually very long list of DeviceLink profiles that you can simply take and use in pdfToolbox, for example, to do color conversions. And we actually have a number of customers that have pdfToolbox server to convert documents and that use, for example, the ink save profiles from ColorLogic to do ink saving in a PDF workflow using pdfToolbox, and that works very, very well. So that's the first option that you have. If you're thinking about color transformations, you know that DeviceLink would be much better, but you don't necessarily want to invest in software for that or in the expertise to learn how to build profiles, which isn't to be underestimated. There is quite a bit of expertise that goes into making these profiles. Using the predefined ones might be a good way to go. Now, in some cases, that simply isn't enough. And then there are applications that will allow you to do that. When we look at the ColorLogic product range, then we have to talk about ColorAnd and we have to talk about CoPrA. And let me, again, instead of showing you the slide, let me very quickly open up CoPrA to begin with. And CoPrA is kind of the first step when you're thinking about creating profiles, because it can allow you to import measurements that you've done. So you typically, when you create a profile, you print a whole range of color patches, and then you measure them, and then based on those measurements, you will build your profile. Well, what we find in practice is that the measurements are often wrong. And that is because the device does something bad, or the measurement device does something bad, or the person actually measuring these things, which is not always a fun job, does something bad while measuring. And if you have errors in these measurements, then you have errors in the profile afterwards. So CoPrA allows you to look at the measurements you have in when you start making a profile. So these are all the measurements that were done, but it allows you to look at these measurements in all kinds of interesting ways, and seeing, for example, that there are some bumps in the curves that you have here, or that you have a spider web where there are certainly defects, or you have some double measurements here and there. So there are errors in there, and what CoPrA allows you to do is, in a relatively easy way, fix the problems that it finds. And if I then look again, you'll see that the curves are now much better. I don't have these double measurements here anymore. If I look at these, they're smoothened out quite a bit. Of course, you don't lose the essential details of the device, but there are a whole number of errors that you typically find in measurements that can be corrected. So that's typically, when you think about making your own profiles, that's typically the first step, cleaning up measurement data. And CoPrA is nice because it's a relatively inexpensive tool that allows you to do this cleanup, and that has a very visual way of looking at the results. But the most important application in this sense is actually CoPrA. And CoPrA allows you to create a printer profile, which is basically an ICC profile. So this would allow me to measure a number of patches, as you can see here, and then do a number of calculations, and out comes an ICC profile with that gamut and the transformation curves that we talked about. But CoPrA also allows me to build a DeviceLink profile, and I simply want to click on this one because it shows very nicely that in a DeviceLink profile, I have to choose an input and an output profile. So I can choose, as in our example, ISO coated as the input, and then I could choose ISO uncoated as the output. And now I can build a DeviceLink profile based on these two and based on these settings that I have. And if I simply open this up just very quickly, the only thing I want to show you is this area here, the exception area. That's exactly what I was talking about when I said that a DeviceLink profile is capable of preserving black and other primary colors, and preserving secondary colors like red, green, and blue, and doing all kinds of exceptions for colors that you want to treat in a certain very specific way. And CoPrA allows you to define all of these and then build a DeviceLink profile based on that. And as you can see, and that's the last thing that I'm going to highlight here, as you can see, it also allows you to build a save ink profile specifically. And again, as you can see, in this case, it allows me only a single profile. Why is that? Well, in our example of when we talked about save ink in DeviceLink, I told you that in that case, the input and the output profile is the same, and it's simply the color mix that is being changed. That's exactly what you see here. This one profile that I select, will be used as both the input and the output profile in the DeviceLink. So that's the second step if you want. If I go back to my presentation, if you're wondering where do these ICC profiles come from and where do these DeviceLink profiles come from, well, if you don't find what you need in one of the pre-built sets, or you want more control over the process, then you can buy an application such as CoPrA, and CoPrA will allow you to build ICC profiles and then build DeviceLink profiles. And again, I included in the presentation as a separate slide an idea for you of the actual cost involved for the different options. In all fairness, ColorLogic typically has a lot of options when you look at their software. It can be configured in all kinds of different ways. And what I'm mentioning here is a suggestion of some different versions of CoPrA, for example. There are many more options. So if this is something that you're really interested in, don't hesitate, just send us an email and we can look at what the actual cost would be. We're not quite done yet. There is, if you look in the ColorLogic product family, there is another product that is important, and that is ZePrA. And ZePrA in purpose comes closer to what pdfToolbox will actually do. What I told you is that pdfToolbox is not capable of creating profiles, but it is capable of processing PDF files with those profiles. Well, ZePrA is exactly the same. You won't build profiles with ZePrA, but you will use ZePrA to change colors in TIFF, PSD, PDF files, and change them either using ICC profiles or using DeviceLink profiles. So why would I buy ZePrA if it's more expensive than pdfToolbox, and pdfToolbox can also do a number of other things? Well, it's a very good question. And the answer, of course, is that ZePrA does these color conversions, but it also has a very long list of additional color-related functionality that really sets color handling apart from what you can do in pdfToolbox. And to name only a few, you can do things like applying custom curves to colors as you're processing. Or you can convert spot colors to CMYK, but there is a full spectral matching engine built into ZePrA that will give you a very close visual match between those spot colors, even for spot colors that are special, that are opaque or partially opaque. It will give you a very close visual match to reality. That's something that you can do in ZePrA, but that you will not be able to do in pdfToolbox. And then perhaps one of the more common but very important parts is, see this line where I said using DeviceLink profiles, pre-built or dynamic, and that's a very important one. pdfToolbox is capable of using pre-built DeviceLink profiles. If you have a DeviceLink profile in that DeviceLink add-on that I talked about, or you created your own DeviceLink profiles with CoPrA, or you used one of the DeviceLink sets from ColorLogic, then pdfToolbox is capable of applying those to your document. But remember that a DeviceLink profile always has an input and an output profile. So if I have this DeviceLink profile that goes from ISO coated to ISO uncoated, and then I have a workflow where I receive files from outside, and someone sends me a Japan color profile, then this DeviceLink profile will not work because this one expects ISO coated as an input. And so if I have a workflow where I receive a number of files from the outside, or where I don't know in advance what kind of ICC profiles are going to be in the files that I expect, then either I have to keep building new device link profiles each time I get such a file, or I need to do something that is a little smarter. And ZePrA does something that is a lot smarter, actually, and that's what I refer to with dynamic device link profiles. What ZePrA does here is it looks at the input and output ICC profile, and it says, well, if I already have a pre-built profile for this color combination, I'm just going to use it. But if I don't, the example of this Japan color file, if I don't have a pre-built device link profile for this color combination, I'm going to build it on the fly. And you actually don't need to do anything. ZePrA will automatically build this new device link profile with the input and output profile as required. It will automatically build it and then cache it for you so that it can be used afterwards. The advantage is that you don't have to do anything, but you still get device link technology to do the color conversion for you. And the pre-built or handmade device link profiles might be a little bit better quality-wise, but the dynamic device link profiles that are built by ZePrA are definitely going to be much better than simply doing an ICC color conversion with all of the loss of color separation that we talked about before. So in essence, yes, the ZePrA application does do a number of things that pdfToolbox can also do, but it has a wide range of functionality that goes beyond that, and again, depending on the functionality that you need, you're talking about something that has a cost of anywhere between 2,500 to 8,000 euros. Okay, that was a quick overview of some of the color theory that I wanted to talk about, specifically color theory as it is related to ICC profiles and device link profiles, and then an overview of some of the software packages where you can use these things. And it's only an overview. I didn't have any time to go into much depth, but I do hope that you understand now what the different tasks are in a workflow like that, what the different types of profiles are, and where you could use which, and which application could help you in a particular workflow. If you have any questions, then now would be a good time to type them into the GoToWebinar interface. I already have a few that I'll look at now, but don't hesitate to enter your own as well. So the first one, how do you handle CMYK color in a PDF when there is no output intent and no ICC on the color? That's a very good question. So basically, what you're asking, let me go back, close this one that we fixed. If I have this document, well, this document does not contain any ICC profiles, and it doesn't have an output intent. So there is nothing that tells me what that CMYK is that I have in the document. So if I now do a color conversion, what happens? If I do a color conversion, I always need an input profile and an output profile. Now, I know the output profile, that's what I want to convert to, but what is the input profile? It's certainly not in the file. That's correct, and what I'll do is allow me to bring up the fix-ups here, and what I want is a color fix-up, and we'll take the convert color. So this looks very, very complicated, but it's really not all that complicated. What it says is, what do you want to convert to? And I keep using the same example. I want to convert to ISO uncoated. Okay. Now, do you want to embed that? Yes, I want to be nice. Once I have the color converted, I want to put it into my file as an output intent. Now look at this section here, assumed profiles. Assumed profiles is exactly what it says. If I have a file that has, and I have an object that has an ICC profile attached, then that ICC profile will be used. If I have a file and an object that doesn't have an ICC profile attached, but the file has an output intent, then the output intent will be used. And if nothing is specified, so I have content without ICC profiles attached, and I have no output intent, then pdfToolbox will use these assumed profiles as the input profile. So what I could do is say, well, if someone hasn't specified anything, I'm going to assume that they made this for ISO-coated, and I'm going to assume if it's RGB that it was sRGB. I'm going to assume a slight dot gain profile, but I could just as well use sGray as the gray profile. So if there is nothing as input profile that pdfToolbox can get from the PDF file itself, then it's going to use these assumed profiles as the input profile. Is that correct? Maybe not, or probably not, but you have to do something. If you're asking pdfToolbox to do a color transformation, then you have to give it an input profile. And that input profile can be attached to the object, it can be in the output intent, or last case, it can be this assumed profile. So that's how that particular one is handled. And then your follow-up question, yes, you have that. Totally correct. So what you're saying here, basically, Jan, is if it doesn't contain anything, we're guessing, right? Yes, that's essentially what you're doing. But that is also why the PDFX standard forces people to include an output intent in there, because then the color is well defined, and if you don't do that, then you don't know what you're doing, and you're basically guessing. Now, you can still question whether that output intent that you have in there is correct. So if I go back for a second, and I open this this file up again, so the one that we fixed. This one has an output intent, and it says ISO-coated. Now, I don't know whether that is correct or not, and it is very difficult to figure out whether it is correct or not. ColorLogic actually has or had an application that could help with this. But even then, you're still guessing. It's a little bit more of an educated guess, but you're still basically guessing what it is. pdfToolbox allows you to do both. It allows you to either use that output intent, and so basically assume that your customer is correct and knows what he's doing, or it allows you to not use that output intent. And that's basically saying, I don't trust what my customer put in here. I'm pretty sure that it's going to be not correct, and I'm going to use another profile. The tool that ColorLogic had for that is called DogBees Profile Tagger. Thank you, Stefan. Is the pdfX3 or pdfX4 standard better on ICC profiles? I'm not going to answer that directly. What I will do is tell you the following. What I talked about was the pdfX1A standard, and in pdfX1A you can only have CMYK and gray and spot color, and you can only have an ICC profile in the output intent. The next logical step is, and I know that some people use pdfX3. It depends a little bit geographically. It seems to be used more in the German-speaking part of the world than in most other locations. But what we see now is, and I think that's more important, is we see a movement from pdfX1A to pdfX4. And the difference between pdfX1A and pdfX4 is that pdfX4 does allow complete color management. And that means that the objects that you have inside of the PDF file can be tagged with an ICC profile. So if you look at my example file again, that might mean that the output intent of my file is iso-coded, as it is here, but that this penguin image that I have is an RGB image that has an sRGB profile attached to it. And that can be a valid pdfX4 file. It could never be a valid pdfX1A file because it contains RGB. But that also leads to one of the big differences between using pdfX1A and using pdfX4. If I use pdfX1A, I know by definition that I'm in a CMYK workflow. And yes, I can have issues such as converting from one ICC profile to another ICC profile, CMYK ICC profile. But I know that that's the limit of it. If I switch to a pdfX4 workflow, then all of a sudden I'm in a situation where now I can get content that has all kinds of different ICC profiles. This file that I get might have 5 different RGB ICC profiles on the cover page because the pictures come from 5 different photographers and they all have them tagged with a different profile. And dealing with a workflow where you use pdfX4 is a lot more complicated than dealing with a pdfX1A workflow. It also has big advantages. pdfX1A doesn't allow transparency, for example, so that's a little bit of what's a big hindrance in many workflows. pdfX4 does allow that. So there are advantages and disadvantages, but if you only look at the color part, pdfX4 files in terms of color can be much more complicated than pdfX1A files. If you look at what the Gamut work group is doing as a standards organization, then we're basically in a transition period, if you want. All of the specifications we have today, or almost all of the specifications, are using pdfX1A, and we're slowly developing specifications that are built on pdfX4 and that allow color spaces other than CMYK. And yes, that means that the applications that you have in a workflow that deals with these files needs to be better or more advanced, if you want, on a color management side than in a pdfX1A workflow. It also means that the responsibility shifts in a number of cases. If I give you a file that contains 5 different RGB profiles and I ask you to print it, then you are going to have to convert that to CMYK. And that conversion means that you have some form of responsibility over the file. And if I afterwards come back and say, well, you didn't do the conversion right, then we have a problem, right? So the responsibility, because of this, the responsibility shifts in the direction of who is printing the file. Now, the Gamut group is actually looking at moving forward with workflows where RGB is allowed for in a number of cases, specifically where it would be allowed, for example, to have RGB image content, not necessarily vector or text, but image content in a document. Those specifications are being created. In some other cases, national organizations have are a little bit further already. An organization like pdfX Ready in Switzerland, for example, already has specifications where some of these things are actually allowed, and they have very good results with using these specifications. But it is it is an important transition, and it does make having good color tools a lot more important in a similar workflow. Okay. I think that's the last question that you, all of you asked. I just wanted to look one thing up, and that is, if I go back, and I'll correct that in the final version, Earl, you're absolutely correct. I have the colorlogic.de website on here. I should actually add to that the crossxcolor.com website, which is their US counterpart for the same solutions. But you have this last slide with a number of these useful websites. You can see this tutorials URL that I pointed to that has all of the previous recordings, and this recording will be added to that. Again, thank you to join. It's summer. I don't know how it is where you are, but it's very, very, very hot in Belgium at the moment. So thank you for taking an hour away from the sun and learning something about color. There will be 3 more or 4 more webinars in this summer school series. You find all of the links, agendas, and the way to register on the 4Ps website. So if you haven't done that, have a look at those and subscribe to anything that interests you. They're all on Wednesdays at 4 p.m. That's easy. And I hope to see many of you again for one of the next webinars. Have a great day.